Good morning to one and all. In today's lecture, we'll discuss about the properties of your joint PDF and joint CDF. That is joint distribution function and joint probability distribution function. Now, as we know that your CDF is bounded between 0 and 1. So, if we put your capital F x comma y as a real value number, that is your capital Fxy is minus infinity to minus infinity, then it is equals to 0. That is the same case of CDF. And if we put for f x comma y as infinity to infinity, then it is equals to your unity. So as we can see, this is same case as we have discussed in CDF. So this is the first property. Coming on to the second property of CDF, as CDF is a monotonic non-decreasing function of single random variable x, then the joint CDF is also a non-decreasing function, which means that your x2 is greater than x1 and y2 is greater than y1. Then your capital F x1 comma y1 is less than equals to your fxy x2 comma y2. Now coming on to the properties of joint probability distribution function. Now coming on, it is denoted by a small fxy, that is equals to the derivative of your CDF fxy x comma y upon del x del y. So coming on to the properties, as it is a non-negative function for all values of x and y, so it behaves as a monotonic non-decreasing function. So your fxy x comma y is greater than equals to 0. Now coming on to the second property, that is the total area under the curve that is the joint probability is unity, that is denoted by double integrating your fxy, that is dx dy is equals to 1. Now if we extend our discussion to joint PDF and your marginal density function. Now in joint PDF and marginal density function, to understand marginal density function, we consider a joint distribution function, that is denoted by your capital F x comma y is equals to your probability of capital X is less than equals to small x, while y capital Y is less than equals to small y. So it is denoted by fxy is equals to double integrate. So for our convenience, we took x as psi and y as eta. So we took your psi is equals to minus infinity to x and your eta is equals to minus infinity to infinity fxy psi comma eta d psi d eta. Now we simply take a finite range of one of the variable, that may be your x or as well as your y, and put the finite limit to the other variable. So we can see over here your capital F x comma y, that is x comma infinity is equals to your psi minus infinity to x minus infinity to minus infinity fxy eta comma psi is equals eta comma psi d psi into d eta. Now this capital fxy x comma infinity represents your marginal density function. Same for y, we can do it. For y it is capital F x infinity comma y is equals to double integrate minus infinity to infinity eta comma y eta to y fxy psi comma eta into d psi comma d psi into d eta. So here your infinity and y represents the marginal density function for y. So we note a point that the PDF for single random variable, that is your capital X or capital Y, can be obtained from the joint PDF over entire range of the other variable, that is called as your marginal density function. Now if we differentiate both with respect to x, then we can see that your small f x is equals to d by dx of fx is equals to minus infinity to infinity fxy x comma eta into deta. Since your integration is with respect to x, so it cancels out. Clear? Same we can do it for with respect to y. It will be your fy is equals to d by dx of fy is equals to integrate minus infinity to infinity fxy eta comma y d8. Clear? So this was all about the properties of your joint PDF and CDF, as well as we have seen these are known as your marginal density function or your marginal distribution function. Thank you.